This is first of a few videos on how to solve buffer-related questions. Calculate pH of a solution containing this concentration of ethanoic acid and sodium ethanoate. So we start our equation. A buffer equation is nothing but weak acid equation. So ethanoic acid, CH3COH, the last H is the one that you can lose, plus water, H2O, pure liquid. Partial dissociation produces ethanoate and hydronium, which is nothing but hydrogen for us, aqueous. Then again, we do ice calculations. Initially, you have 0.200 mole per decimeter cube of this acid. Usually, if you remember your ice, we had 0 of ethanoate and 0 of hydronium. But in a case of buffer, you also have some salt, and the salt is what's going to give you the conjugate base. So this time you really have 0.250 mole per decimeter cube of this substance, although you still have no hydronium. So that's your initial. Now there is a change, and we always follow left to right, so you will lose X number of moles from your reactant, and you will produce X amount of moles on the product side. Then there is, of course, equilibrium, E for that, and we bring down the numbers, 0.20 minus X for your acid at equilibrium, 0.250 plus X for your conjugate base, and finally X for hydronium. They're challenging us on pH, so I really need to find out what X is. So now let's just write our equilibrium expression or constant. So K, dissociation constant of the acid, is products over reactant. So it's CH3COO times hydronium or hydrogen divided by concentration of CH3COOH. Ka is given to us in the problem. It's 1.74 times 10 to minus 5 is equal to, now I'll just put 0.250 plus X multiplied by X, that's my products, divided by 0.20 take away X. Now then again, we don't want to solve anything quadratically, so we do our assumption, which is always works because Ka's are usually smaller than -3 magnitude. So our assumption is Ka is so small, it's much smaller than 1, that we can say anything added to X or subtracted from X is the number itself. So 0.250 for numerator plus X is nothing but 0.250. And for denominator, 0.200 take away X is approximately equal to 0.200. The only X that doesn't go is the X that is being multiplied. You need that. So now let's just see what happens to our simplified equations. 1.74 times 10 to minus 5 now simply becomes, numerator you have 0.250 multiplied by X divided by 0.200. Now let's just solve for X. So X is 0.2 times this number divided by 0.250, and when you do that, you will find it is equal to 1.39 times 10 to minus 5. Now don't forget, X is nothing but hydrogen or hydronium concentration. So pH is negative log of H, and when you do that, you will get 4.86. So equilibrium, buffer calculation is same as ice equilibrium. But now I'm going to give you a shortcut and one equation to memorize, which makes life easier. This is after two scientists, Henderson and Hasselbalch equations, and for short I call them H and H. Now if you realize the question is buffer, you can find its pH just by having this equation going, pH equals pKa plus concentration of salt over acid for acidic buffers, and for basic buffer is pOH equals pKb times concentration of salt over concentration of the base. Now this is a similar question to question 1, and I'm just going to apply this, and without much time on calculations, you come to your answer. Calculate pH of a buffer solution containing propanoic acid and sodium propanoate. The equation is not needed, but let me just write it. C2H5COOH is propanoic acid. Equation of the weak acid and buffer are exactly identical, and you have propanoate aqueous plus hydronium. Now you can do ice calculation, or you can simply, if you have memorized this, by solving few buffer questions, it will be memorized, is pKa plus log of concentration of your salt, which is your conjugate base, divided by concentration of your acid. pKa is given in your booklet, or in this question it's given 4.87, plus log of, now what is concentration of the salt? Sodium propanoate is 0.450, that's your numerator, and concentration of your acid is 0.550. So this is 4.87 plus, now log of this number, get log of less than 1 is always negative, so this you will get minus 0.0872. So pH is equal to 4.78. This is much quicker calculation than ice, but the condition is you have to remember it the way it's written. It's concentration of salt over acid. If you do vice versa, your pH is in the neighborhood, but it's not exact.